Yeah, hi guys, good morning.
Anna late already.
Good morning.
Good morning.
Yeah, hi,
Good
good morning.
morning.
I can see Potan in this channel. Potan, are you there?
Yes. Hello.
Yes, Potan.
Hi, Sabeto.
Nice to see you.
Thank you. Thank you so much.
Yeah. So guys, let us start. So in today's session, we will be working on EKS. Okay, so first let me share my screen. Can you see my screen?
Yes, Sabeto.
Yes.
Yes.
Okay. So we have something called EKS. EKS means, what's the full form for EKS?
Elastic
Kubernetes
Kubernetes
Services.
Yes. Elastic Kubernetes service. Okay. So this service is specifically provided by AWS. Means what will happen is, so whenever we have set up our KubeADM in our previous sessions, right? So when we set up KubeADM, we were responsible to manage the worker machines. Sorry, the master machines, right? So we used to set up the master with the help of KubeADM. We used to install all the important components of master. Okay, and then we used to join the worker machines. And if the master is available or not, everything was our headache to take the backup of etcd, okay, to make sure kubelet is running, to make sure all the operations are getting performed. So we used to manage all that configurations. But when we are using Kubernetes service, which is managed by AWS, right? So the AWS will manage all the worker machines, managing all the master machines, right? So no need to worry about master. The only thing what we need to do is you need to set up your worker machines. Guys, go on mute. Hotan, go on mute. If you have any questions, then unmute and ask, okay? So AWS will be managing all the master machines. Means no need to worry about how many masters are configured, whether kubelet is running or not, whether we are able to get all the health checks required from the worker machine. So everything will be taken care by AWS only. We will be just only working on worker machines, right? So EKS is one of the Kubernetes service provided by AWS, and this will be the complete engine of Kubernetes. Means what all the components which were available in Kubernetes, everything is available in AWS EKS as well. So in interviews, you might expect questions on EKS as well. So whatever components we have learned, daemon set, stateful set, persistent volumes, every component is same. There is no change in terms of components. Even the commands will be same. So do not worry about the components and commands. Everything is same in AWS EKS as well. Okay. So now we have some additional advantages when we are working on EKS. So what are those advantages? So we can try to integrate with AWS services. Means if suppose you want to attach your pods to the load balancer, then this will be very easy. If you want to monitor your pods with the help of CloudWatch or with the help of AWS managed Prometheus server, this is also very easy. Okay. And apart from that, if suppose you want to authenticate different set of users, for example, in our project 10 members are working and you want to provide access to specific users, then we can integrate IAM, right? So in our regular Kubernetes, which self-managed Kubernetes, so we used to install networking solution, either Flanner or Calico, right, to assign the IP addresses. But when it comes to EKS, no need to set up Flannel or Calico. We will be using VPC CNI. This will be the advantages if we are working on EKS service, right? So we have something called add-ons in EKS. So what do you mean by add-on? Add-on will be the additional benefits. So we have lot of add-ons which will help us to integrate with our Kubernetes cluster. For example, I want to perform monitoring. Then I can use add-on and then I can set up metric server. That metric server will help you to monitor your pods and node machines. I want to set up IP address, means networking configuration. So I will install VPC CNI add-on. I want to give one ID card to my pod. Then I can use service account. We have something called service account, which is very important, right? So these are different add-ons which are part of EKS cluster. Now let us try to set up Kubernetes cluster first. Okay. So let me go to my AWS account. Let me first try to sign in. Let me just sign in, guys. 1 second. Okay. So this is our AWS account. Let me just refresh this page. Okay. So let me go to my EKS service. Okay. In this service, if I'll go to cluster, then here you can see zero cluster, means we haven't created any cluster yet. So we have two configurations. I mean, if suppose I want to create any cluster, I can create either from the graphical user interface from GUI or by using CLI process. And before setting up, we have something called EKS CTS tool. EKS CTL. So this command line interface or this command line tool is very powerful to set up Kubernetes cluster. Means earlier we used to use kubeadm to set up our Kubernetes cluster, right? So if suppose I want to set up EKS, I can use EKS CTL tool. This tool will help you to easily set up your cluster. Okay, so in my machine, if I'll open my git bash, okay, if I'll do EKS hyphen version or else version, I can see 0.207.0 means it is already configured in my laptop. And the process is very straightforward, guys. You can see any documentation. If you type install EKSCTL using PowerShell on Windows, then you can get few commands which you can use and set up EKSCTL. Right? Since we have already worked on Kubernetes and DevOps, right? So it is not a difficult process for us. Clear? Hope you can set up this EKSCTL. So once EKSCTL is done, then you need to set up your AWS configure. Means this is nothing but our access key and secret key to communicate with our AWS account. So in my case, I have already set up my CLI as well. Okay, done. Now let me go to home location. Okay, in this particular folder, I am having one file called EKS freetire.yaml file. So if I'll open this file, here you can see we are having specific set of content. API version EKCTL kind cluster configuration means to set up my cluster, either we can use console, graphical user interface or CLI. So in this case, I'm using CLI. Why? Because CLI is very easy to configure. Okay. So I have created one YAML file. Okay, this YAML file will be having all the details related to your cluster. The name of your cluster will be medium EKS cluster. The reason why we are keeping this as medium is because the size of instance type, what I'm using is T3 medium. Okay, and then it is set up in the region US East 1 and version is 1.28. So which version of Kubernetes we are trying to set up? 1.28. And then we are trying to configure VPC and the access will be 0.0 means anyone can able to access our cluster. Okay, and then we have something called node groups. Node means, what do you mean by node?
Node mean machine, worker,
Node
and
means
stuff.
Worker
worker
node.
machine or virtual machine. So what we are doing is we will be creating one group. That group is called as node group, and inside that group all our worker machines will be placed. Okay, so what do you mean by cluster? Cluster will be a combination of master machine and worker machines. But in this case, we have something called node group. Node group will help you to manage all your worker machines. And whenever we are trying to set up with the help of node groups, this will be very easy for us to scale. Means, for example, if you want to create new node machine, then node group will help you to auto scale this. Auto scaling, what I will do, I will attach to node group and that will help you to scale new node machine. Okay, and then the name of this node group is medium node group and the instance type is T3 medium, and here we are trying to configure desired capacity is 2, minimum 2, maximum 3 means at least I need 2 worker machines. If you are seeing lot of traffic, then it should automatically scale to 3 worker machines. This scaling we call as cluster auto scaling. What do we call as this? I mean, we call this as cluster auto scaler, CA. We call it as CA, cluster autoscaler. So what cluster autoscaler will do? This will help you to create new node based upon the pending nodes. We'll discuss about this in detail. Okay. And then we have the volume size. So what should be the EBS volume which we are going to assign, and then our SSH key, and this is my PEM key which is already available in my account. Okay, and then we are trying to configure few IAM policies. and then we have tags related to our environment. Clear? So now we got our EKS free tier YAML file. Now I want to set up one cluster using this YAML. So how many ways we can set up? Either with the help of CLI or with the help of console. CLI is very easy. Okay, so let me use CLI. I will be sharing these notes as well. Okay, let me use this create cluster command. So we are using EKS create cluster, and then file name is eksfreetry.yaml. Let me hit enter. So what this will do? This will try to set up our cluster. Here you can see 0.207 is the version of our EKSCTL, and this is the region which we are trying to set up our cluster, and we are using these two subnets from our VPC, and it is trying to create one node group name as medium node group. Okay, and the key will be used as EKS-cluster. Okay, and then it is trying to set up our cluster. And also here you can see CloudWatch logging will not be enabled, means you will not be having the default monitoring. You need to enable it. And if you want to enable it, then you can use this command. Okay. And here you can see default add-ons, means the additional functionality which we can easily integrate with our AWS. So we are setting up metric server. This is used for monitoring. And then we have VPC CNI. This is for the IP address assignment. And we have kubeproxy. Okay, this is for the configurations related to our proxy servers. I mean our networking configurations. And then we have DNS. Okay, so all these details will be set up on our cluster. Okay, so it will take 5 to 10 minutes of time to set up our cluster. Clear? So what it is doing, it is trying to execute two tasks. One is our EKS cluster and one is node group. Okay, so this will execute two set of tasks. One is EKS cluster, and second one is node group. And also here, if you can see, cloud formation stack means this automation is being performed with the help of cloud formation template. Okay, so if I'll open my AWS account and if I'll go to my cloud formation service, here you can see. Can you see this EKS ETL medium EKS cluster? Okay, and then the status is create in progress, means this is one service which will help you to manage your infrastructure similar to our Terraform. So by default, AWS is using CloudFormation stack to create our cluster. If you'll go to events, okay, here you can see these are the different configurations which are setting up. Service role, VPC, internet gateways. Okay, and then you can see the status, create completed, create in progress, subnet public, private route table. So all these configurations are getting created in the background with the help of CloudFormation stack. Okay. So this will be very easy for us to manage, even if you want to delete, right? So you can just execute one single command, EKS, CTL, delete, and then cluster name. Then it will delete the complete cluster. Okay. So let us wait. It will take 5 minutes of time to complete. Okay. Till then we can discuss these notes. So here, whenever we are trying to create any particular EKS service, right? So it will be creating couple of IAM roles in the background. See, the moment you execute EKS create cluster, then it will use all the default value and create the cluster for you. Means if suppose I'm executing this command without passing any YAML file or without passing any parameter, then what it will do? It will take the default values and it will set up the cluster. So it will create EC2 worker machine with the capacity of memory optimized MX5 something, right? So we don't want such high capacity of instances. That's the reason what I have did. I have specified one YAML file and I have used the default YAML to set up my cluster. Okay. So whenever we are using EKS-ETL, it will create few roles in the background. One role is IAM role for cluster. Okay. And this particular role will help us to communicate with different AWS services. So this role is attached to your cluster. And then one more IAM role for EKS node. This particular policy or role will be attached to your node, means your node group. Again, here you will be creating three different policies. One will be Amazon EKS worker node policy, one will be container registry read only, and then EKS CNI policy. Means this policy will help you to manage IP addresses. This will help you to pull the images from our registry. Which registry are we going to use? ECR registry, right? So we are going to use our images from ECR. And then we have worker node policy, means this will help you to communicate with your cluster and join to your EKS cluster. Okay. So these will be the different roles which will be created. So make sure you remember these two set of roles. This will be asked in interviews. How many default roles will be created? So how many roles? Two roles will be created. Okay. And then we have something called AWS CCM, means Cloud Control Manager. This will be part of your master machine. And this particular Cloud Control Manager is responsible to manage different AWS services related to load balancer volumes. This is the additional configuration what we will be seeing on EKS, Cloud Control Manager. And this is responsible to create different AWS resources. Okay, let us check the status. So it is still taking some time. It will take time at least 5 to 10 minutes. Okay. And then after setting up of this cluster, we will be performing few important components. Means in our previous session, we missed few components related to HPA. So I have missed these services. So I will be adding those services in today's session. So which services we have missed? HPA, cluster auto scaling, and then we have something called Cronjob, and we have something called job. This is very important. Nowadays, I can see a lot of interviews, they are asking HPA and cluster autoscaler services. Okay, so how can we set up cluster autoscaler? How to set up HPA? We are going to work in today's session. Okay. So guys, if you have any questions, let me know. Till then, we can discuss about your queries. Ramesh, you don't have any queries?
Till now, there is no.
Anyone else? Raghu? And once our cluster is set up, then we will be implementing monitoring solution to this cluster as well. So that's where we are going to use Prometheus. And if required, we will be integrating Grafana as well. So what Prometheus and Grafana will be doing, that will help you to monitor the number of pods, number of node machines, what is the status, okay, what's the current CPU utilization. All those details will be captured on Prometheus. Okay. So let's wait for this to get completed. So here you can see waiting for CloudFormation stack. So this is our stack name, which is getting executed in the background. And if I'll refresh, here you can see create complete, and still few of them are in progress. So if you want to check the complete output, right, what is happening, then you can see the events. Events will help you to identify the progress. Okay.
అన్న ఇక్కడ క్లౌడ్ ఫార్మేషన్ లో క్లస్టర్
సారీ చెప్పు రఘు.
అన్న ఇక్కడ క్లౌడ్ ఫార్మేషన్ లో క్రియేట్ అవుతుంది క్లస్టర్ అన్నాం కదా, అంటే క్లౌడ్ ఫార్మేషన్ గురించి మనం నేర్చుకోవాలా మనం?
అవసరం లేదు బ్రో.
ఓకే.
See, we can, by default it is creating its own stack and setting up, right? So if you got one requirement to set up one EC2 instance with the help of CloudFormation, then you need to understand what is CloudFormation, how to write the template. Even if you'll see now, here in template, okay, you can see this code. So this is how we are going to assign one CloudFormation template. Means you need to specify all those details related to service, I mean, which is your provider, and then different resources which you need to create. Okay. So
Okay.
no need to understand CloudFormation, because we are going to focus on this part, I mean Terraform. Okay. And again in EKS, we can set up the cluster by using two configurations. One is either you can set up EKS EC2 for worker machines or EKS Fargate, similar to our ECS, right? So for now, I have been using EC2. Why? We know the reason, right? So this will have the complete control on our cluster. Okay. So now, if you'll see this, our particular cluster setup has been successfully completed. Okay. And then we can see it is trying to create add-ons. VPC CNI add-on is successfully created. Qproxy successfully created. CodeDNS is successfully created. Now it will try to create metric server. Metric server is very important in today's session. Already it has created, sorry. Yeah. Here we can see metric server is also created. Okay. So now this will try to create our node group, means our worker machines. Let us go to our cluster. If I'll refresh this, here you can see one cluster is active and the version is 1.28, and you can see the official support which is available till November 26. Means after that you will not be able to get the support. So before November 26 you need to migrate to another version. That's what they are trying to say. Okay. So if I'll click this cluster, here we can see a lot of options. Okay. For now, in add-ons, we can see only one metric server add-on, Qproxy and CNI. So these are different add-ons which has been installed. Even if you want to install any add-on, right? So just click on get more add-ons and then we can set up. So in our previous task, we tried to connect from our open source Kubernetes to EBS volume, EFS volume. So what we have installed few plugins. That plugin was nothing but add-on. Clear?
Yes, sir.
Yes, sir.
Okay. So here, if I'll go to compute, then we can see number of nodes which has been created. So this is not yet done. It is still waiting. Okay. And here under resources, you can see all these details. I mean, if you want to check how many pods are there, then you can click here. As of now, it has created 4 pods. These pods are installed on master machine. Okay. Now it is trying to create one more stack. Here you can see deploying stack node group means it is trying to create your worker machines. Now if I'll go to my cloud formation and refresh this, here I can see one more stack is getting created. If I'll go to my events, then we can see a lot of services which are getting created. See, okay. So once this is done, then our cluster is ready. If you want to update, right? For example, as of now, I have given the configurations to create 2 worker machines. For example, after 1 month or 2 months, I want to make it to 5. Then no need to set up the complete cluster. You just need to update the node machine. So we have command EKS ETL update config node group, and that will help you to update the number of worker machines. Okay. So let us see. There is no difference, guys. The only difference is in terms of additional advantages of or features, which will be part of EKS CTL. Apart from that, every configuration is same. The most common thing what we are going to create in EKS is IAM policies and rules, because that is something which will help you to communicate between multiple services, right? So you need to always create IAM rules and policies. So we'll wait for a couple of minutes, then this setup will be successfully done. I will be sharing these notes. So once after this session, try to use these notes and try to set up the cluster.
Now, what is the main difference between the Qflux and VPC CNI, which will give the IP to the pod, assigned to the pod?
See, basically VPC CNI, what it will do is it will use the VPC network interface and assign the ports. In our previous configurations, we were using kubeproxy, okay, and we were using networking solution Flannel or Calico. Okay, so that used to set up the configurations and then set up the IP addresses. But in our case, VPC CNI will help you to manage the IPs. No need to worry about the IP assignment. Okay, so now if you'll see this, our cluster is successfully completed. Okay, so here you can see waiting for the control plane to become ready, and then it saved some file called kubeconfig. So where this has saved under C users mohammad.kube and then config. And then here you can see node group has 2 nodes, and this is the name of our node machines. And then here you can see node group is created and EKS cluster is also ready. So now my requirement is to connect to this particular cluster. So how can we connect? Means let me open again our cluster. Okay, here you can see 2 worker machines which are available, T3 medium, which has been created. Now if I'll go to my EC2 instance, if I'll go to the dashboard, running instances, I can see 2 instances has been created, and these are running successful. 1 second, guys. Yeah, sorry guys. So two worker machines has been created successfully, right? Now, if you want to connect to this particular worker machine, then we can connect. Here you can see this. We have the IP address and I can use our SSH-I and what's our PEM key? So we have assigned one PEM key initially, right? So that was something called EKS cluster, if I'm not wrong. Yes. So this is my PEM key, which is available in my laptop. I can use this PEM key and I can connect. But I don't want to connect to these worker machines. I want to connect to the master. I want to perform some commands. Where can we perform? Here, if you see this, EKS, the moment we are trying to set up our cluster, it is telling us that there is one file called kubeconfig which is saved in this location. Means this kubeconfig file has all the configurations to connect to your cluster. In our previous sessions, we executed one task to connect our cluster from our local machine. Yes or no?
Yes.
Yes, yes.
Right, so what we did, we copied .kubeconfig. .kubeconfig file has all the configurations related to cluster. So if you have this file, then you will be able to connect from anywhere. This will be asked in interviews, which file we need to copy or how can we set up or communicate from our local machine. So you need to answer about .kubeconfig file. Okay, so this file is already downloaded in my Windows server. So no need to worry about this. If I'll execute our command kubectl get nodes, then based upon this file, you will be authenticate to our cluster. See, now we can see these are two nodes and the age is 6 minutes 55 seconds and the version is 1.28 and this is EKS service. So everything you will be controlling from your local machine only. No need to connect to XYZ server. No. You will not be able to connect to master. If you want to communicate to your worker machine, then you need to execute commands in your local machine only. Understood?
Yes.
Okay, let me clear the screen. So kubectl get nodes. Sorry. So here we can see two worker machines are available. Now I want to schedule one pod. Means our regular task to create pod, to create service, to expose them, to create volumes, okay, PV, PVC, secrets, config maps, everything we want to execute in the same manner. So what we can do? So we have one file called deployment.yaml or nginx.deployment. For example, nginx.deployment. So this is my YAML file. So what this YAML file is doing, this YAML file will help you to create one pod. Okay, and then the image will be Nginx and the resource request will be 100 MB of resource, which is limit, sorry, request, and 200 MB will be our limit and it will be exposing on port number 80. Hope you can understand this YAML, right? So no need to explain these YAML files,
Yes.
right? So now I want to create my YAML file. Okay, so how can we create?
It's literally apply.
kubectl apply -f and then deployment file name,
File.
kubectl spelling. So what it will do? It will try to create one pod, right? So if I'll do kubectl get pods, then we can see one pod has been successfully deployed and this is running. On which particular node this is running? How
We
to
need
know
to
that?
set kubectl git pod hyphen override.
Get for -i.
Hyphen override.
This will help you to know on which particular node machine. So this is running on 55.67. Actually, this is our node name. That's the reason we are unable to identify. Okay. So we need to execute our regular process. Means whatever you want to set up to pods, deployments, everything will be same. Clear? So now let us focus on HPA. So we have something called HPA. So what is the use of HPA in Kubernetes?
Like if you want to increase our parts whenever the traffic will be heavy, like automatically create want to increase our parts based on the traffic. There we can go for the HPA.
Okay, see here in this particular configurations, our number of replicas is 1. If for example, if there is a lot of traffic on this Nginx pod, so what will happen? This pod will get crashed, right? The number of
Yes.
replicas is 1 means this will be standard. It will be running only one pod based upon the desired state. This is what the user wants to create. Now, if there is heavy traffic, then the pod will be crashed or the performance will be very slow because this pod doesn't have enough capacity to handle a lot of traffic. So in order to avoid such cases or such situations, we use HPA, horizontal pod autoscaler. And these particular HPAs will help you to automatically scale the number of pods based on metrics. So what kind of metrics we used to use for autoscaling groups?
CPU utilization.
It can be CPU utilization, it can be disk space, memory, right?
Yeah.
Or the number of users at the load balancer. So even HPA will use the same metrics. Okay. Now I want to monitor the metrics. So we have one command called kubectl top node. What's the use of top command? This will help you to know the CPU utilization, right? So I want to know the CPU utilization of my node machines. Say current CPU is 38 MB, okay, 1% out of 584. This is the current usage. Now I want to know the CPU utilization of my pod, kubectl top pods. So what this command will do? This command will provide the complete 3 MB memory is been utilizing and 0 core because there is no traffic. This is just an empty static pod which I have created and ignored it. We don't have any traffic or no one is trying to access this particular pod. Okay, so from where you are able to monitor these metrics? Earlier in our previous sessions or else in our previous cluster, try to execute these commands and check the output. It will not throw any output because in order to fetch all these details, you need to set up metric server. Which server? You need to set up metric server. This is default which is provided by Kubernetes only, whether it is for KubeADM or EKS. You just need to set up metric server. And if you'll see our EKS cluster, we have seen one add-on got created, right? So this metric server is pre-installed. Okay, so no need to install this metric server again. If you'll see this, get pods -n cube system. All those default pods or components will be available in cube system namespaces. Okay, here you can see metric server, right? So this metric server pod is already available. And where is this component running? In both these master as well as worker nodes. Master, we will not be configuring master, right? So that's the reason you will not be able to see the master pod. Here I can see 2 pods which are running for metric server, and these 2 pods are running on 2 worker machines. And from this metric server, you are able to identify the number of usage related to CPU and memory. Okay. So now I want to test this metric server. Sorry, I want to test my HPA. Means I want to implement my HPA for high availability of my application. So we have already set up our nginx.deployment. This is already running, right? So no need to update anything in this. So now let me set up one HPA YAML file. Means you need to create one YAML file, and the kind of YAML file will be horizontal auto pod autoscaler, and then you need to define what is your target. You need to specify, or you need to tell your HPA that this nginx.deployment is your target. Here you can see nginx.deployment. Here also we have the same name. Okay. And then here we are trying to specify minimum replicas. Means you should maintain at least one replica. And if there is an increase in usage, then you need to scale up to 5 pods. And on what metric you need to maintain or scale? Metric will be CPU. And the target value here I am using 50%. But when it comes to our projects, it will be around 70 to 75% what we are going to implement. Here I am using 50% so that we can easily scale. I mean, we just need to test this. Okay. So now let me execute this HPA. Okay. So this HPA file is also available in my machine. If you don't have, then you can try to copy this. Okay. So HPA. So here you can see hpa.yaml. Here we have this HPA file. Now let me apply these changes. Apply -f hpa.yaml. Okay. Now we can see that HPA has been created. Now if you'll execute kubectl get HPA, sorry, kubectl get HPA, then you can see nginx HPA deployment, and the target here is unknown. Means the value is 0 because our nginx pod, it is not, there is no traffic. So still it is taking some time to fetch these details. So here inside this unknown field, you will be seeing the number of or the percentage of traffic, and the threshold value is 50, and the minimum is 1, maximum is 5. As of now it is 0. So let me try to execute again. Now here you can see 0%, 50%, and then one pod is running. Clear? So if you are able to see these values, it means your HPA is working as expected. Now I want to test this. So how can we test this? So this will be working based upon the CPU utilization. So either I need to log into this pod, kubectl get pods. Either I can try to log into this particular pod and try to increase our CPU utilization by executing some random operations. Or else I will create one random container. Okay. So here we have load generator one container. This pod, what it will do, it will try to add some fake load to your pod. Means this is just trying to check for the service in Nginx. So what will happen? The number of CPU utilization will be increased, and then we can test our HPS. Okay. So before doing that, so let me execute this nginx service. Means why are we going to use service files? So service file will help you to expose to the outside world, right? So now I want to expose my nginx pod. So we have this nginx node pod service. So here we have this. So let me try to execute kubectl apply -f nginx service.yaml. So the service is created, kubectl get services. Then we can see Our Nginx service is exposed on 3080. So let me just try to access this on browser. This is my pod, right? Sorry, worker machine. What's the port number? 3080. 300. Yeah. Here we can see that our service is available. Our pod is also configured, but I am unable to access this on browser. So what might be the reason?
We have to expose that.
We have already exposed. If you'll see this kubectl,
Yeah.
describe service and then service name, then you can see the endpoint. See, already my pod is already attached. Okay. So still we are unable to access. Why? If you are unable to access any port number, then that might be issue related to your security group. That is very easy. It will be the problem with firewalls, right? So let me check security group. In security group, we have two security groups. Okay, so let me open this. Let me add inbound rule. Here we have HTTPS, so we don't have any port number which is opened, right? So let me just try to make it all traffic. Okay, I have updated one security group. Let me update another security group. There are two security groups which are attached. Let me add one more rule, all traffic, and this is to 0. I mean, for now, I'm just opening all the port numbers. Let me refresh. See, now we can see welcome to Nginx. Means we are able to access our service, I mean our application from outside world, right? So we have successfully set up our pod as well as our service. Now, these commands I have already executed. This will help you just to know the metrics, right? Now let us add some fake load to our Nginx deployment. So let me try to execute this YAML file. ls, where is this load generator? This YAML file is available. kubectl apply -f and then load generator YAML. Okay, if I execute kubectl get pods, this YAML file, if you'll check this status, right? So it is just trying to execute few commands by using busybox image, and it is trying to connect to our service. This is my default service which I have created. This is just executing one while loop and trying to connect to my service continuously. So what will happen? It will increase the CPU utilization. Right now, if I'll check this kubectl get pods, sorry, get HPA. Now we can see it is 34%. Means the CPU utilization has been increased because of this load generator YAML file. Now let me again check. Still 34%. Okay, so within 2 minutes, what will happen? It will cross more than 50, and then our HPA will trigger the creation of new pods. kubectl describe HPA and then name of HPA. Let us see the events. Always try to monitor the logs. Okay, always try to monitor the logs. Always try to check the events. Okay, here we can see the HPA was able to successfully calculate a replica count desired within range. Means Earlier it was 1 and it was able to match because the CPU utilization was low. Okay. Try to access this URL, try to add some load. Everyone, please try to just click on that URL and try to add some fake load. Just try to refresh. It will generate some load on our application. I've shared that URL in Slack. Guys, in the meantime, if you have any questions, let me know. Any questions on HPA? You should get, or else let me do one thing. It is taking a lot of time, right? So let me try to update this YAML file and let me update this target to up to 20% only. Okay, then it should scale. kubectl apply -f. I'm just trying to update the target value. Now we can see this 25, right? So the target was 25 and our current usage is 35. So if I execute kubectl get pods, then we can see one new pod is getting created from last 7 seconds. If I'll execute again, or else let me check HPA. Now here you can see number of replicas is 2. So what HPA is doing based upon the CPU utilization, it is trying to calculate how many resources pods we need and it is trying to create new pods automatically. Once our CPU utilization is down, then it will delete the old pods. So basically this is one kind of auto scalings which are getting triggered. And these auto scaling we call as HPA. This is only for pod auto scaling. Understood? Is this clear?
Yes.
Yes.
Any questions on
Yes.
HPA? So how to set up HPA? First is you need to set up metric server and then you need to configure one YAML file for HPA and one our application related deployment and service file. That's it. You need to just specify the target. In HPA, we are just specifying which particular deployment you need to target. And then we are trying to check the threshold values. Okay. Now, let us ignore this HPA, it will automatically decrease. Okay, or else let me delete this kubectl, because this load generator pod was trying to add some load, right? So let me just delete this pod. This got very slow because our capacity of our node machines, this is only T3 medium. So once my load generator pod is deleted, so it is terminating. So once this is deleted, what will happen? This pod will also get deleted because the CPU utilization will be back to normal. Okay. So now we have something called cron job. What is the use of cron job in Linux?
To automate the task on that particular time or
Right.
day.
Particular schedule.
So even in Kubernetes, for example, if you want to perform any specific task on the specific schedule time, then we can use cron job. Okay. So what this command will do, I mean, this concept of cron job is to perform some kind of operations at the specific period of time. For example, you want to take the backup of a server. Then I will create one pod with all the configurations related to backup, and then I will schedule one cron job. This cron job will help you to execute and finish the process. Okay. So if you'll see this YAML file, the kind will be cron job. And then here we are going to specify the timing. Same concept. There is no change. And then we are able to configure. I mean, what should be the history limit? In Kubernetes deployment, we used to configure the revision history, right? So here also we can try to save the history limit. I mean, whether it is successful, how many successful history details you need to configure. 3. How many failure? 1. So all these details you need to configure. And we are trying to configure the restart policy on failure, means if this pod is failed, then it should restart. So what are we going to do? We are just trying to execute one date command. See, I am just trying to execute one date and then printing one message. So let me try to apply this particular YAML file and check what will happen. And this is for every 1 minute. Okay. So if you'll see this, I do have this YAML file cronjob.yaml. So let me execute this command to apply the changes. This is created. If you'll execute kubectl get pods, see, this pod has been completed 5 seconds ago. So what will happen? This will be completing, means once on that particular every 1 minute, this pod will start complete its task, and then the status will be completed. And here you can see 0/1 means there is one pod which needs to be executed and the current status is 0 because the job has been successfully completed. Okay. Now I want to test my cron job, means we have executed this date, right? So I want to check. So how can we check? With the help of pod, I mean with the help of logs. Okay. So if you'll see kubectl get cron job, then we can see the number of cron jobs which are being configured. This is one. Okay, and then kubectl logs and then name of my pod. Here you can see it has printed the date. What's today date? Monday, April 28th, and this is the timing based upon UTC, and then it is trying to print our message. So if you want to run any script which will help you to take the backup, then what I will do, I will try to configure that script in this YAML file, and that script will be executed based upon our scheduled time. Clear? This will be asked in interview. What's the use of cron job? So
clear.
cron job will be completed once it has been successfully executed. The task, the status will be completed. Then we have something called job. So we have something called cron job and we have something called job as well. So what is the use of job? What's the use of job in Kubernetes? See, cron job, what it is doing, it is trying to execute based upon the schedule. But job will help you to execute for a one-time activity. So once that particular task is completed, then that job will be stopped. Okay. So cron job is for every particular schedule and job is to execute for one-time activity based upon your requirement. I will be scheduling one job. This job should execute one script and that will execute the script and that will get completed. So job will execute only once. Cron job will execute multiple times based upon schedule. This is the overall logic behind cron job and job. This will be asked in interviews, difference between cron job versus job. Okay, clear? So this execution, I haven't did this. I want you guys to check on this and try to execute one sample job. Okay, so now then we have something called secret manager in Kubernetes. Not in Kubernetes, sorry, in AWS. So what is the use of secret manager?
Store sensitive
Those
data.
are
Sensitive
secrets.
data, it will encrypt
Right.
data.
So how to store sensitive data in Kubernetes?
Secrets.
Secrets will be there.
Secrets.
AWS secrets.
Right. So how to create one secret?
By the
For
help of
example,
a
password is
.env.
at the rate. Once again, for example, password is at the rate 123. So what we do first, we will try to encode it. Right. It will create one random number XYZ 1234 something. With the help of that number, no one will able to guess your password. But if they have installed base 64, anyone can try to decode. Yes or no? Have you observed this?
Yes.
Yes.
Right. So anyone can able to decode. So that's the reason we will be avoiding multiple secrets. I mean, if suppose we are using Kubernetes, open source Kubernetes, so I will be adding multiple secrets to the same file. First, I will try to encode, and then for that encoded key, again, I will try to add one more encryption. I will try to add multiple encryptions to make it very secure. But instead of maintaining all these encryptions, the best solution is use secret manager. That will be asked in interviews. What if that particular encoded key has been leaked? If someone got that key, then they can also you download base64 install and they can try to decode. There is no security, right? So we use AWS Secret Manager, and AWS Secret Manager service will help you to store any secret information. So how are you going to store secrets in Kubernetes? With the help of Secret Manager. Okay. In your interviews, you can talk either about open source Kubernetes or EKS. Any what we call experience is fine. Okay. So now, how to create secret manager and inject that secret inside our pod. So let us try to execute this. Okay. So first thing is we need to create one secret. Okay. So let me use this name. I will be using the name as DB credentials. Okay. Let me go to my secret manager service. Okay. Click on store a new secret. Okay. I will be using other type of secret. User key. Password. Admin 123. So this is my username and this is my password. Okay, click on next. And then this is my secret name, DB underscore credentials. and then let me click on next. Okay, 1 second guys, let me just check. Okay, let me use some other name. Let me add one secret code password. Admin are there 123. What's wrong? I'm using different name db-credentials1 because in order to test, I have already created one secret. That's the reason it is unable to. I mean, I'm unable to create secret with same name. Okay. So let me scroll down. Let me click on next. Okay, what's the benefit of secret manager in AWS? So if you are using secret manager, right? So one thing is it will be very encrypted, and also you can implement auto rotation, means our secrets or our credentials will be automatically updated for every 7 days or 10 days. Okay, so for now we don't need all that configurations. Let me click on next. Let me click on store. Okay, so I have created one secret and the name of the secret is DB credentials. Now I want these details to be configured inside my EKS cluster. I mean inside my pod. Okay, so the second thing is you need to set up one OIDC, Open ID Connect. So what is the use of OIDC? Guys, try to remember these keywords because this is what we need to implement to communicate with our services. So these particular configurations will help you to create one token, means whenever you are trying to connect to your EKS cluster, right? So this will be passing one token for the authentication, means any pod who is trying to authenticate or communicate with other AWS services, this will be providing one token for authentication. This is just to enable the trust. Okay, so how can we create this? You can just use this command, and this command will help you to create this OIDC token providers. Okay, so before executing, just try to update your region and cluster name. So let me try to set up this. So my region is US East 1. So let me update to US East 1. Okay, and then my cluster name is medium EKS cluster. So this is my cluster name. Let me hit enter. I am using EKS command. So this command will help you to easily install all the providers which are required. But for our operations, I am using kubectl. For any kind of installation, for any kind of updatation on the cluster, we are using EKS Okay. So now we can see created IAM OpenID Connect provider for cluster. So for this is one-time activity, guys. Once you have set up, then it's okay. So now we have ensured that this particular cluster is a trusted one, and we have created that relationship. Okay, and then now we need to create one IAM policy. So why do we need IAM policy? Because you need to communicate from secret manager to EKS, right? So how to establish communication between multiple resources across our AWS with the help of role. So what I will do, I will create this policy, and this policy will be attached to my IAM role. And in this policy, you can see this effect is allow, and we are trying to fetch the secret value from where? Secret manager. And this is my secret manager details which I need to update now. So what you need to update? You just need to update your region. This is nothing but region, and this is the account ID. So this is my account ID, and then this is the secret name. So in my case, I will be adding one because this is my secret name. DB-credentials 1 is my secret name. And here you can see something called hash, sorry, star. So asterisk, what's the use of this star? Why do we need star? What will happen is, if you'll see this name, db-credentials one. So if I'll go to my secret manager, okay, and if you'll check this secret ARN, we are trying to pass the secret ARN, right? So secret manager ARN, this part. Okay. So after your secret name, it is creating some random 6 to 7 digit random number, which is automatically assigned. So you will not be aware about this number every time. So if I am using star, it means anything which starts with this particular secret and then anything which will be ending. Okay. So this part is static. This will be fixed based upon your configuration. This will be generated, but this is a random number. In order to identify, I have updated this. Okay. So now let me copy this. Let me create one policy with this name. You can create any name, guys. Okay. So let me go to my IAM. Let me go to policy. Let me copy this name as well, because I guess in my account a policy will be already available here. Here you can see secret manager access. So this policy is what I have created as part of testing. So just let me try to update this because the name has been changed, right? So let me update this. In your case, you can just create one policy and copy and paste this JSON file. In my case, let me update one. Okay, now we are good. Let me save. Okay, so our policy has been created, and then you need to create one role with custom trust policy. Means your role will be trusting this policy. Okay, so let me go to my IAM role and create one role with this particular name. So in my account, that role is also available. In your case, you need to click on create role, provide the name and the details. Okay, if I'll click this role is already available. This is the policy which I have attached. Just now, whatever we have created, I have attached this policy, and under trust relationship, I have provided these details. So in these particular details, you can see this. We have something called string equals, means here it is asking you to provide the OIDC ID. Which OIDC? Open ID connect, which just now whatever we have created. Okay. And then service account means which namespace you want to target and what is the service account name. So if you'll see this is my OIDC account details. So this is for my account and the service account is default, and this is the service account which I haven't created. I will be creating with the same name. Okay, so how to fetch these details now? So I have shared that command as well, if I'm not wrong. Okay, so in order to identify the OIDC ID, let me just check the command. Okay, so if you are trying to describe or use this AWS EKS command and try to update your cluster name, Okay, here you can see this. So I need to update my ID as well because this ID has been updated. Okay, so here you can see the complete ID. So let me just copy and update my trust policy. And remaining details, my account ID, everything is same. Okay, namespace is also same. So I will not be updating anything. So this is my default namespace and this is my secret. What happened? Let us just try to update this.
In principle, federated also we have same
Yeah,
thing.
yeah. Let me just update. Okay, so this is updated and let me click on update policy. Okay, so now we have the access to access our AWS Secret Manager, and this OIDC will help us with the authentication. Means this will help us to provide the identity. Here you can see this definition. Okay, trust the identity of pod means your pod will have the identity to communicate with that particular secret manager. Okay, so this is also done. Now step 6, we are going to create service account. So and my service account name is secrets.sa. So this is what I have passed here. Okay, so let me just use this YAML file. So we have this YAML file, service account. Let me cat. Okay, so here we are just trying to pass the account ID details. You need to update this account as per your account. Now let me try to execute kubectl apply -f service account.yaml. So what will happen? This particular service account will be used as an ID card. So what is the use of service account? Service account will be used as an ID card for our pods. And this will help you to communicate with the Kubernetes API and other AWS services as well. And this is very secure. So this is the whole process to access your secret manager. One is you need OIDC, that is to create trust for your pod. And second is you need to create service account. So service account is used as an ID card for your pod to communicate or connect securely. Okay, so we have successfully connected our service account as well. Now let me create one deployment.yaml. So in this deployment.yaml, I am just trying to use the service account name. This is my secret, and then I am trying to access my secret manager. Here, if you see inside this container, I am just trying to pass one AWS CLI command, and this CLI command will help me to access my DB credentials, which is available in secret manager, and then it will try to update the output in JSON format. Clear? So let me go to this YAML file. So I'm trying to access this particular secret inside my pod. In Kubernetes, what we did, we have injected with the help of literal file or with the help of our
Directory env.sh.
directory.env, right? So here we are trying to inject with the help of command. Okay, so deployment.yaml. I'm just trying to update the name because we have updated the name, right? So secret one, let me save and then let me execute this YAML file -f. Okay, this deployment is also created. Now, how to check the secret means how to test our task, whatever we have implemented. So how to test? So you just need to execute logs. And we are trying to segregate with the help of secret app means this is my label. Okay. So I'm just trying to access the logs of the pod with the label called secret app. Hit enter. It will take some time because that particular image is related to Amazon Linux, right? So it is trying to install few important packages. Okay. So here you can see this. So this is trying to download all these packages. Okay. Now here you can see password is admin@123. Have configured. So we have used only one field, DB credentials. This is my DB credentials. Okay. So here, this is my password. So I have stored only one key and the password is 123. So this is what we can see on screen as well. Understood? So this is how you need to inject your secrets from secret manager. So which one are you going to use in your project? AWS secret manager. If you are talking about EKS cluster. Just remember the process. No one will ask you to write the YAML file and all that stuff. They will ask you the process. So you need to create one OIDC that will act as an trusted entity for your pod, and then you will be creating one service account that is nothing but one ID card for your pod to securely communicate with AWS services. Okay. So done. So this is how you need to set up our secret manager. Guys, any questions?
No.
No.
So, Saber bhai, so we can inject these secrets like as usual methods, right? So we have,
Yes.
yeah.
See,
Okay.
if we are trying to use the secret manager, right? So end of the day, if you are using -f literal -file, Devi ఎక్కడ వెళ్తున్నావు? Can someone ask Devi where she is living? సెషన్ నడుస్తుంది, ఇంపార్టెంట్ టాపిక్ ఉంది, నాకు కూడా దాహం అవుతుంది. Okay, this is something which will be asked in interviews. That's the reason I have been trying to cover. I have missed this part in the previous sessions. So end of the day, if you are using -f literal -file -env.sh, right? So everything is we are trying to inject inside the pod. Even now, we are able to see our ID, I mean the password inside our pod only. So no need to use -f file or other parameters. You can just directly try to use service account and map with your pod. Okay.
Okay, Saber.
So now this will be our final topic for Kubernetes as well as for EKS. Okay, so we have something called cluster autoscaler. What is the use of cluster autoscaler? See here, kubectl get nodes. So earlier we have increased pods, but my task is to increase nodes. Means as of now here, how many nodes are there? 2 nodes. Okay, so let me just check one deployment cat test.deployment. Sorry. Okay, this deployment, if you see this deployment here, we are using 500 MB CPU and 512 MB memory for our containers. Means this is my resource request and limit, and the number of replicas is 2. So if I'll execute this particular apply -f test.deployment, so what will happen? We have the enough capacity currently on our node machines. kubectl get nodes. Sorry, kubectl get pods. So we have the current capacity which is already available. See here, you can see 2 pods are running, and this is our, sorry, 2 pods, 2 was our requirement, right? So 2 test deployments are running successful. Now, for example, the user desired state has been updated, means I have updated this deployment to from 2 6. I have updated to, instead of 6, let me update this to 7. Okay, so I have updated to 7. Now I'm trying to redeploy my application. Okay, so what happened now? If you'll see kubectl get pods, few pods will be scheduled. See here you can see this is Nginx, so ignore this part. So focus here. How many was the desired state? 1, 2, 3, 4, 5, 6, 7. And out of these 7, few pods are running. Okay, and few pods are pending. Why this is in pending state? Let us try to check the events. Describe deployment, and then the name of the deployment is test.deployment. Okay, here you can see scaled up. Okay, from 7, from 2 desired state, only 5 available, 2 unavailable, means out of 7, 5 pods are running, 2 pods are not running. So let me just try to describe this pending pod and see what is happening, why this is not getting scheduled. Here you can see 0 by 2 nodes are available, means there are 2 nodes, but there are 0 nodes for this pod to get scheduled, and insufficient CPU, means whatever resources we have assigned to our worker machines, that has been already utilized by the existing pods. See, whatever pods are in running state, these pods have already used all the resources. Now we don't have enough resources for us to schedule new pods. So that's where we use cluster autoscaler. So cluster autoscaler, what it will do, it will help you to scale the number of worker machines based upon pending nodes. So it will always monitor pending nodes. Okay, there are 2 pending nodes. Now I need to scale 1 new worker machine, and then it will scale. Cluster autoscaler will scale based upon the pending nodes. And also here, if you'll see, the moment we have created one cluster, it has created one auto scaling groups. Means the scaling will be implemented with the help of auto scaling groups only, right? Let me go here, auto scaling groups. Okay, here you can see EKS ETL medium, right? So how many instances are running currently? Worker nodes 2, and my desired capacity was 2 initially. If you remember, I have used EKS ETL YAML file, right? So the maximum what I have requested was for 3. So this is the auto scaling group which is being used to scale up and scale down. Now I need to tell my cluster autoscaler that we have one auto scaling. Please use that auto scaling and manage the number of worker machines. Clear?
Yes, sir.
Yeah. So how to do this? So first thing is our cluster autoscaler. We call it as CA as well. Sometimes CA or cluster autoscaler both are same. So our CA should be able to identify which autoscaling group should be used, because there might be multiple autoscaling groups. As of now, we are in testing process, so we have only one autoscaling. So our cluster autoscaler should which autoscaling group should it use? So first what I will do, it will always try to identify based upon the resource ID, and then you need to pass the details, means this value should be true and this value should be 1. So here you can see cluster autoscaler details. So these are nothing but tag. So here if I'll open this what, here if I'll go here, tags play very important role. Okay, here you can see these tags. Okay, can you see these tags? How many tags are available? Let me click on edit. So how many tags are available?
12.
12. So these are the tags which you need to update. Either you can update with the help of this command. This will help you to know the name of your auto scaling group, and then you can try to pass these details, and the resource type should be auto scaling group. Okay, let me open this console. Okay, these values I can try to update. Key is k dash. Okay, so one should be, sorry, 1 second. One should be true and one should be on. Means here, if you see this, here one should be true, one should be on. So based upon that particular details only, your cluster autoscaler will be communicating with the autoscaling group, that will combine with that autoscaling group and try to launch new instances based upon these tags. So these tags, updating these tags is very important. Clear? Without updating tags, your autoscaling group will not be able to communicate with cluster autoscaler. Okay, so let me just try to execute this command. This command will help you to fetch the name of your autoscaling group. That's it. Okay. So how many nodes are there currently? Let us just check this. We are having only 2 worker machines. Okay. So this will help you to get this name of the autoscaling group, right? Now I'm just trying to update this. So let me just copy this command. Let me copy this command. Okay, let me paste. And let me try to update the resource ID. Here we have this resource ID, right? So we need to update this resource ID with the name of your EKS. So what we are trying to do, we are just trying to update the tags. Okay, so one more resource ID, because we are trying to update 2 tags. Tag updation is very important. Based upon this only, your cluster autoscaler will be communicating. If you are not updating these tags, then it is of no use. Okay, let me hit enter. So this command will help you to update these tags. If the tags is not available, then you can also create. This command will help you to create as well. So do not worry if these tags are not available by any chance. Okay, so I have updated the tags. Yeah, we'll wind up in 10 minutes, guys. Don't worry. Okay, and then you need to create IAM policy for cluster auto scaling. So this policy, what it will do, this policy will have all the permissions which are required for your auto scaling group to communicate with the EKS. So EKS or your worker nodes will have all the permissions. So just go to your IAM policy, use these configurations. So add this as your policy name and use these configurations and update your policy. Clear? In my account, this policy will be already available. Okay, in your case, just try to create this and then set up IAM service account. Again, we are using service account. Why? Because service account will help you to provide the ID card for our pods, right? So let me just create one service account. Let me copy. Okay, this should be my account ID. So let me update. So this policy is already created in the previous step. So this policy is available. So I'm not going to update this. But in your case, since it is not available, just try to create. Okay. And then my cluster name. So what's my cluster name? Medium-EKS cluster, right? media. Always cross check before adding any names, because a small mistake will not be able to attach to the same configurations. Okay. So it is taking couple of minutes to create the service account. So once the service account is created, then you need to deploy cluster autoscaler YAML file. So we can use this GitHub repository and we can just try to add. Okay, so what this GitHub repository will do, this is having the predefined YAML file which I will be using to set up our cluster autoscaler. So this service account is also getting created with the help of CloudFormation stack only. Okay. So now let me set up my cluster autoscaler pods. Where can I find this? These pods, if you'll check kubectl get pods -n kube system. Similar to our metric servers, right? Sorry. Namespace. Yeah, -n and also kube system. Okay, here you can see cluster autoscaler. It is running successfully one by one, means this is okay. Okay, now one second guys. Okay, so this is successfully running. Now let us try to update the deployment, means whatever we have deployed, I just want to update it. Why? Because you need to update your cluster name. So we can use this command, and this command will help you to edit the existing deployment. Okay, so just open this file, and if you read this notepad, here I have clearly mentioned that replace with your cluster name either in arguments or command under container specifications, means so this is my YAML file. Okay, under the container specifications, where is my, yeah, here we can see container specifications. Here you can see this part, right? So here try to update this with your cluster name. This is the mandatory configurations, means we are telling our CA that this is our cluster which you need to continuously monitor. Okay, EKS medium EKS cluster, right? What was my name?
Yes. Medium.
Confirm, huh?
Cluster. Yes.
Okay, okay. So let me save this, and once this is saved, then we can see this has been edited successfully. Now we can try to check the logs of the cluster autoscaler, and these logs will help you to identify what is happening. Here you can see log is held. Autoscaler. This has been updated just now, right? So let me try to check logs again. Here you can see. See now, here if you'll see this 0 pods marked as schedule, means our cluster auto scaling is working perfectly as expected. Here you can see no scheduled pods. Okay, pod default. And here it is trying to identify these are the 2 pods which haven't scheduled. Let me open git bash. One more git bash only for our understanding. kubectl get pods. Here you can see where is our this one 94 HIDF, right? This is pending, and HNMVJ. This is also working. I mean, this is also pending. So what our cluster auto scaling is doing, it is trying to check which pods are pending status. And then based upon the details, he estimated 1 node is needed. Means it has calculated that we need 1 new node. And this new node should be attached to our node group. And the current capacity is 2. And the maximum the user has set is 3, means we can create 1 new node. So what it will do, it will try to scale up. Here you can see scale up. Okay, now if I'll execute kubectl get nodes, here you can see one new worker machine is added. Here you can see this 41 seconds ago. Now if I'll try to check the pods, kubectl get pods. All these pods are in running status only. Yes or no?
Yes.
Yes.
Right. So now if suppose the deployment, for example, what was our deployment? Test deployment, right? So test deployment, if the request has been decreased to 2, now there is no need of new worker machine. So what it will do? It will wait for the cooling period. The cool down period is for 10 minutes by default, which is configured. So it will wait for 10 minutes and then it will try to delete one node machine. Clear? So it will take 10 minutes of time to delete the new node machine. So this is how cluster auto scaling will be working. Clear? So EKS is also similar to what we have learned in Kubernetes. There is no change. So have you guys found any changes? No, but EKS is much more easier. Means no need to worry about master machines. Everything will be maintained by AWS. Whatever you need, you want VPC, CNI install, you want metric server install, you want service account, OIDC. So try to install them and try to communicate with your AWS services. This is very easy to integrate. Right? So this is one of the easiest concept. Kubernetes is very easy. The only thing is you need to understand the components, which component is doing which job, and what is the responsibility of each component. Then you are good with Kubernetes. Okay, guys, any questions?
Like, what is the main difference between this one, EKS and Kubernetes? If someone asks why we are going with some companies with the EKS or
See, if you
Kubernetes.
want to avoid the maintenance part from the worker master machines, then you can use EKS. And EKS will help you to easily integrate with AWS. Means if your complete environment is on AWS, then better to use EKS only, because that will help you to easily integrate with different AWS services. Right? So this will be the one of the greatest advantage for EKS. If your complete infrastructure is on Azure, then go for Azure Kubernetes service. If your complete infrastructure is on GCP, then go for Google Kubernetes Engine, GKE. And Azure Kubernetes Service, GKE, EKS, three concepts are same. There is no maintenance headache. But the billing will be high. Since they are managing, they will add lot of billing. Okay.
Okay.
Guys, if you have any questions, let me know, or else we can wind up this call. It's been almost 2 years. Oh, sorry, 2 hours. Okay. So silence means no questions. Both try to call me up whenever you are free. Okay. Just give me a call.
Sure.
I will be sharing